Good morning, good afternoon, good evening, good night. My name, at least for the purposes of this discussion, is Top Nugget, and welcome to another AI Learning Bytes session. Today, we're dealing with, as we have been dealing with the last few sessions, AI fundamentals. And we are going to talk today specifically about foundation models. Now, last time we learned that a model essentially is the brain of the AI solution. All of the thinking happens in that brain or that model. We're going to learn a number of terms today. So what are foundation models? Foundation models are large, very large AI models which are trained on a large amount of data. Now, remember we said models are like the brain. Imagine training for those models being a situation where you pull together a whole set of data and you teach the model that information. When I say very large, there are foundation models that have been trained on the entirety, or at least they say they've been trained on the entirety of the publicly available internet. Like everything that's available to the public, they know they've been trained on. All right, so we teach that brain all of that information. That's what training or model training is. Now, as a result of that, these models can do a large number of things. They understand, let me go back, sorry. They understand your language and they can answer questions. They can write text. They can summarize information. If they were trained on images, they can generate images, new images that never existed before. They can generate speech and audio if they were trained on these things. They can even generate programming code if they were trained on sufficiently large amounts of programming code. Now, few things to note. Number one, this training for these models does not happen on an ongoing basis. The training requires that a large amount of electricity is used to train those models. Those models require, the training itself requires the use of what are called graphical processing units or GPUs. And those GPUs require a large amount of electricity to run on a consistent basis. Training can take anywhere from a few hours to, depending on the size of the model, days or even weeks to complete. So those GPUs need to run all of that time. We have to provide power for those GPUs to run all of that time. And those GPUs, once they get past a certain threshold, will get very, very hot and can catch fire. That's correct. That is possible. So to keep that from happening, the training also includes a whole set of cooling. A whole set of complex cooling solutions are typically put in place to make sure those GPUs do not overheat. The end result of all of this is that training of models is very expensive. Um, the cooling, the power to run the GPUs for those prolonged periods of time usually comes up to astronomical amounts of money. So because money is not an infinite resource, what we have to do, or what the large model companies need to do, is train a model, test it, make sure it's good, and then release it out into the world, into the unsuspecting public. So models are trained and released, and therefore they are then available. Now that's important to note because of the next fact that I'm going to share. Because the training of the model is a single exercise that happens at a period in time, the model will not have in its foundation, in its data, information that happened after it was trained. So if we had a model that was trained in 2025, that model cannot tell you unequivocally who is or who has been, who has gotten into the latest round in World Cup football or soccer, as some people will call it. The model cannot tell you that because the model's information does not go into that part of the future. It stops at 2025. That's what it knows. No, I said the model cannot tell you that, but that doesn't mean it won't try. The way these models actually work is that they don't actually know the answer to anything. They look at what is in their foundation and they make an educated guess as to what the next set of information would be or should be that they should say. All right. If it's a text model, what they should write. If it's a speech model, what they should say. If it's an image model, what the image should look like. But it is an educated guess based on what is in the foundation. If the information is not in the foundation, it does not mean that they're not going to make an educated guess. They may still try. And that is where we run into some of the challenges we're going to look at on the next session with hallucinations and drift and bias and whatnot. But for right now, just understand that if the data is not in the foundation, the model does not know it, it may still try to guess what the answer is. All right, now, large language models. I just kind of want to classify some of these models so that when you see these terms, you will know what we're talking about. LLMs are large language models, are foundation models that are trained on large amounts of text. So written text, words, letters, etc. They're trained on large amounts of text. All right. Because of that, you usually interact with them using text. So natural language, you will say something or write something to the model. Not necessarily say, usually write text to the model, and the model will respond with text. That what you write to the model is what is called a prompt. Okay, so what you tell the model, that can be a question or instruction or a request. That's what's called a prompt. And the model will generate what it thinks is the next best answer or response to you based on what you have written and what is in the foundation that it has. All right. This allows it to help with a lot of things, including rewriting documents and brainstorming. I use models for brainstorming, LLMs for brainstorming all the time, and explaining things. Now, there's one other term I want to touch on before we leave this slide. And the next, the term is token. So I said that these LLMs, large language models, generate responses based on what they think probably will come next based on what you've said and what's in the foundation. They don't generate it as words, though. They generate it as what are called tokens. A token is about equal to 0.75, like 3/4 of a word, essentially. But it's more than that. It also is equal to essentially a section of a sentence, all right, that the model breaks its words into, all right? So it's just a way of the model being able to count how much it's going to tell you. Tokens are used to gauge how expensive a model is. So the responses from LLMs are usually in the form of not necessarily words, but tokens. The responses from LLMs are gauged by tokens. So the cost of a model is essentially how much are you charging me per token, per input token, like what I say to the model, and per output token in terms of what the model is sending back to me. That is the reason why the word token is important is because we have to use that word to understand how expensive a model is to use. It's an indicator of the cost of the model, the cost per token. All right. Now, I'm gonna mix it up a bit now because there are other types of foundation models besides LLMs. Um, as I said, large language models are concerned with text, but then we have models that are concerned with images. All right. So, and those models take in a huge amount of image information, and that's what's in their foundation. And then they respond based on what we tell those models. All right. What we send to the model. We might send an image, it may give us back an image. An example is stable diffusion. Funny enough, stable diffusion is actually pretty small, so small that I've run it on this laptop that I'm using right now to record this video in the past, and I tested it a couple of times, worked pretty okay on this laptop actually. Um, so you can, some of these models are small enough to run on your home computers, and those are, even though we call them a large language and large image, some of them are actually small enough to run in those scenarios. There are audio generation models or speech models. Those models are like, some of them are held by a company called 11 Labs. They're one of the more popular vendors of speech models. There are models for generating music. So a whole lot of music was put into those models. They understand a whole lot of music, how music is put together, and therefore they can guess what comes after a piece of music, and they can add and add and add pieces until they generate an entire song. There are video generation models like Cdance. I use that all the time for a lot of my video generation experiments. So lots of different types of models. All of these, though, are foundation models, are types of foundation models, music, um, video, image, etc. Now, let's take it one step further. This is the last slide in terms of learning new information. Let's take it one step further. There are those models, and you could think about it for a moment, it's logical. If you want to generate an image, you want to be able to tell the model what you want. In some cases, you want to be able to tell it with speaking, like what I'm doing right now, or using your voice, or you may want to be able to tell it by typing something with text. Back in the day, the way that had to work, because each type of foundation model did its own thing, this is the way it kind of had to work. When you said something, oops, let me go back. Yeah, here we go. When you say something to the model, it has to go through a speech model or speech to text model that takes those spoken words and turns them into text. Then that text has to go to your large language model, which takes that text and generates a response based on what is written in that text. It writes a response, right? A text answer, which goes back to another speech to text model, sorry, text to speech model, which takes that written text and turns it back into words, and that is what you hear. Now, as you can see, this is quite complicated, and this actually takes a while to run. It took a much longer time to run before. We've gotten quite good at it, so it's a lot shorter nowadays. But there are what persons have done is they've said, you know what? It would be so much easier if one model could understand spoken speech, if it could understand images, if it could generate speech, generate images, generate video. Can we have a single model that does everything? And that is what is called a multimodal model. Multimodal, new word. And that's the new word for this slide. Multimodal models can take speech input, it can take text input, they can take image input, and they can spit back out speech, they can spit back out text, they can spit back out images, video, depending on the model. So, the whole idea now is to have a model that is multifunctional. This is obviously a lot faster than doing all of this typically, especially if the model is one that is running on beefy enough infrastructure that it can handle all of that processing. So what have we learned today? And we learned a lot. What have we learned today? We learned about foundation models and how they work, essentially a whole set of data, underlying foundation. That data is what basically decides what the model knows and what the model does not know. We learned about large language models, which are foundation models which are built on text. We learned about other types of foundation models, like those that handle images and video and music, etc. And we learned about multimodal models that handle all of these things put together just to make your life a lot easier. Um, there are a whole set of other things we could say about models, but the reality is I want to talk about next time about some of the things that can go wrong with these models. While all is sunshine and rainbows on this slide, all is not sunshine and rainbows in real life. And I want to talk a little bit about where some of these things can go wrong. And then in the subsequent session, I want to talk about how we get around some of the challenges that occur when these things go wrong. So thank you again for your attention. I know this was a long one, but there was a lot to explain. I hope it makes sense, and have a wonderful rest of the day. Thank you again. Bye.